Welcome to online classes. I am Shilpa, lecturer in DCME, working at Dr. B.R. Ambedkar Government Polytechnic, Karimnagar. As we are discussing OOP through C++, in that, in previous lecture, we discussed introduction to C++ input-output operators, which already we know. That is C in and C out. How we can get input from the keyboard and output to the screen. Okay, and next we discussed C++ streams. What is mean by stream? Okay, what is the main use of stream here, and what is the hierarchy of C++ stream classes? That is IBOS, iStream, OStream, IBOStream, iStream buffer. We discussed about all these classes and functionalities of those classes. What is the purpose of each and every class, and what are the functionalities? What are the characteristics of all these classes we discussed in previous lecture. In today's lecture, we are going to discuss about unformatted input-output operations. That is in previous lecture as we discussed here. What is mean by unformatted input-output operations? If that is in this, we cannot use format specifiers. So if you are not used any format specifiers, then that is called as unformatted input-output operations. And it takes one input from the user, only one input from the user. Okay, we are not at all using any specifiers, format specifiers like percentile 2.3f or anything percentile and like that. We cannot use for reading or accessing elements into a variable. Okay, so here we are going to discuss some more about this unformatted input output operations and also formatted input output basics. So in that there are mainly two types of formatted input output operations. One is IBOS class functions and flags, and next one is manipulators. If time permits, we will go for that also. Okay, so today's lecture we are going to discuss in detail unformatted input output operations and formatted input output basics. Okay, so here, as all of us know, we have used seen in our all our programs. Okay, but what is the syntax for reading data using input operator? Okay, this is the syntax for reading data. Okay, seen extraction operator variable 1, extraction operator variable 2, extraction operator, so on. So here when we are reading values for these variables, here there is no restriction like v1 and v2 should be of same data type. They may be of different data types. That is v1 may be of type int, v2 may be of float, and some other variable may be of type char. Here we are not at all using any format specifiers like in C. If that is in C, in order to read an integer, we need to use percentile %d. For float, percentile %f. For char, percentile %c. Like that, we need to specify the format specifier when we are going to read value for a particular variable of a particular data type. But here, we need not to specify that. So that's why we are calling them as unformatted, right? And here, this is the syntax, and where this v1, v2, and so on, vn are variable names, and cin is a predefined object. Okay, as we discussed in previous lecture, cin and cout are the objects which are created for the input stream and output stream classes, right? So cin is a predefined object that represents the standard input stream. Okay, it is nothing but here keyboard, and the standard input stream represents the obviously keyboard, because from keyboard only it takes or reads data to a variable. Okay, and the operator is called the extraction or get from operator. It is getting from the keyboard is getting value for a variable from the keyboard. So that's why, or it is extracting the value. That's why this particular operator, that is normally with term, we use the term like two greater than symbols. Okay, it's called the extraction or get from operator, and it extracts or gets the data from the keyboard and stores in a variable as we discussed. And the input data would be here data 1, data 2, so on, data n, or variable 1, variable 2, variable 3, so on. Okay, so if you observe how this input will be takes place from the standard input stream to the program. So here we use this scene object in our program. Okay. So as we discussed, the streams are acts as an interfaces. Acts as an interfaces. So this scene object acts as a stream object that acts as an interface between our program and the standard input stream in this case. So it extracts the data from the keyboard, right? And it assigns them to the variables v1, v2, so on. Okay. Here, narrow end sending to these variables. Okay. This is standard input stream, and this is the object which we use in our program, and this is the extraction operator. Okay, and it sends the data which read from the keyboard to variables, right? This is input using input operator. So like this, the input will be takes place from the keyboard to our particular variables using this object, right? Next, how we can display the data? What is the syntax for displaying, or what is the format for displaying data? Okay, so here already we used see out insertion operator, item 1, item 2, so on, item n. Okay, here this item 1, item 2 are variable 1, variable 2, so all these other variables are constants which we want to send to the standard output. Okay, here the standard output is nothing but screen. So see out is a predefined object like scene also. Okay, like scene, and that represents the standard output stream. That represents standard output stream. Standard output stream is again stream. The standard output stream represents the stream, right? And the operator two less than symbols is called the insertion operator or put to operator. Insertion operator or put to operator. And it inserts the contents of the variable on its right to the object on its left. It inserts the contents of the variables on its right. That is, here always the contents of the variables are at right side. Okay, so it inserts the contents of the variables on its right to the object on its left. To the object on its left. Again, here this cout is an interface, and it simply sends that to what output screen. Output screen, in this case screen or monitor. Okay, it inserts the contents of the variable which are at the right side to the object on its left. Okay, and you can see that in this diagram. If you observe this here, this is a variable, in this case that is a string. Okay, this content is assigned to the object, that is cout. Here the cout is connected to the screen. Okay, so this one narrow side is at left side. Okay, so this will be transferred to the screen. This will be transferred narrow side to the screen. Okay, this is output using output operator. Clear? This is how we can take input, takes from the keyboard, and this object will send to its narrow side, that is here in this operator narrow side, that is the variables. And whereas for C out, it takes the content of a variable, okay, to the C out, because here this narrow side is at left side to the object, and object will send that to the screen. Clear? Now how this input output operations can be takes place in our program. So without knowing in detail about this C in and C out, even without knowing these C in and C out are the objects which are created for the stream classes, till now we use these C in and C out in our programs, right? Till now we use this C in and C out in our programs without knowing much about these two objects. So here, as we discussed, see in and see out, that is objects, or and about that particular classes, and how these will act as interface between program and the particular input output, that is screens or keyboard streams. Okay, to use them. Now this is a simple example. I think we should not, we don't require much explanation about this. Simply here we are declaring, of course, in order to check whether this C in and C out is work for all different types of data types. Here we declared two variables of type int and one variable of type float and one variable name, that is of type character array. Okay, in order to check whether this scene can be applicable for scene can be applicable for all different data types. That's it. If that is in C, using scanf, we need to specify the format specifier. But here, this particular objects do not require that, because they have their own intelligence, as we discussed in previous lecture. Okay, so for that only here we specified all these things. And see out, enter your name. Okay, that is a character array. So we are going to enter some value, and that will be stored to the, and that is keyboard. From keyboard to this scene object will read the information and sends that content or the value to the variable name. Like that here see out. So it gets that is reads this particular uh, string, and it sends to this particular object, and here this object will send to the screen. Okay, and after that we will enter something, the keyboard accepts or receives the data and sends to this object, and here this object assigns that value to these variables a, b, k. Okay, enter two integers and one float. Okay, whatever we enter they will be stored to a, b, k. And see out, thank you, name, you entered, see out A, B and K. That is simply we are printing all the values, that is different types of variables. The values of different types of variables here. We printed them. Okay. This is all about input output, unformatted input output operations. Okay. And this is the output, need not to bother about that. Okay. So till now what we discussed, unformatted input output operators. Okay, how that will be takes place, that is how what is this scene and see out, and how this scene and see out perform operation, that is that particular operation in our program. Okay, and what are the different characteristics of each and every scene and see out object, and how these act as an interface between program and the input or output stream we discussed along with the diagram. Right, now we move to formatted input output operations, or the basics of formatted input output. Okay, so here the C++ supports the following features for formatting the output. So unformatted means we cannot use format specifiers. So obviously here what is meant by formatted? That is, here we can use format specifiers. Okay. From the definition of unformat input output operations, what may be the definition of formatted input output operations, that is here, if we use format specifiers in our input output operation, then that is called as formatted input output. Okay, and here it takes or used to take one or more input from the user. Normally unformatted input output operations takes only one input from the user, but here this formatted, that is opposite to unformatted. So here it is used to take one or more input from the user. Okay, that is called as formatted input output. How it will take one or more input from the user, and how it apply that more than one input on the particular variable or the value. Okay, and how this formatted input output operations are differ from unformatted. In unformatted, we will get unformatted output. Okay, that is normal output. We cannot change the format, that is the way in which the value will be displayed on the screen. We cannot change using unformatted input output operations. For example, if we want to print some value, see out 10000 or 123456 like that. So obviously by default that will be that 1234 start will be printed on the screen starting from the first character on the screen. Okay, that is by default it is left justified, left justified. Okay, so we cannot make that as right justified. Okay, and we cannot specify the width. Okay, so all these operations cannot be performed using unformatted because we cannot change the format of the input or output. Okay, but using this formatted input output operations, we can change the format of displaying the values on the screen. Okay, that is we can print the values as right justified, and even we can fill the empty spaces with some characters. Okay, we can perform some operations, or we can change the format of the output. Likewise, even we can change the format of the input, that is at the time of reading values to a variable, we can change the format. For example, if I want to read a float value, and the float value is having some 10 precision bits, that is after decimal point it is having 10 digits. Okay, but when I am going to read, okay, instead of reading 10 decimal digits, okay, just I want to read only 2 or 3 or 5. Okay, so at the time of reading, remember at the time of reading only, if I want to read instead of 10 decimal digits, I want to read 2 or 3 or 5 decimal digits into a particular variable. So that can be possible using this formatted input output operations. So when we are reading scene, that is when we are invoking this object scene, at that time we need to use some function, predefined function, so that here it will read only 2 decimal points. Okay, and stores that as a value to a variable. Okay, that will of course we will discuss in depth in further. So here C++ supports the following features for formatting the output, in order to format the not only the output, even the input. Okay, in order to format the input or output, C++ is having some features called as, first one is IOS class functions and flags, and second one is manipulators. Using either IOC class functions and flags, we can format the output or input. And even by using these manipulators, we can manipulate the format of the input or output. Input or output. Alright? Now we'll see first one, that is IOS class functions and flags. So IOS class functions. iOS class contains the following member functions to format the output. So it is having some number of, I think hardly 5 different types of uh, member functions to format the output or input. Okay, to format the input or output. First one is width. First function is width. So here what you do, in order to specify the required field size for displaying an output value, we use the function width. Okay, that is in order to specify. Normally, if we are specifying the width, that is 10 characters. So though we are providing some 5 characters, it reserves the 10 characters width to this particular variable. And after this particular statement, again we have written, we are printing some other variable. That though we are not used slash n or anything, the second statement output will not be starts at the end of the first output statement. Why? Because here we specified the width of the first output statement. So first output statement width is 10 and it occupied only 5 characters. It leaves remaining 5 characters as empty. So when we want to print the second output on the screen, it cannot be start from the end of the first output value. Okay, it by leaving 5 characters space, the second output will be printed there. Okay, so that is the use of width. So in order to specify the required field size for displaying an output value, we need to specify the width. And second function is precision. So here all of us know the number of digits to be displayed, that is the number of digits after the decimal point. Okay, so here this precision is used to specify the number of digits to be displayed, the number of digits to be displayed after the decimal point. For example, if we want to print the input in rupees format, so as the input is float, I can, there is no restriction like I should type only 2 decimal points, no, 2 digits after the decimal point. Okay, there is no restriction, that is 25.10 or 25.50, 25.75, 25 rupees 75 paisa. Okay, and normally the that is money is represented in this format. But as that is a float value, I can print 25.751012 like that. I can give that as an input to the variable. Okay, if that is the case, as the always the here the money is represented in only 2 with only 2 digits after the decimal point, we can set the precision. You can set the precision so that whatever this particular variable is having any number of digits after the decimal point, when it is printing or when it is reading, it accepts only 2 digits after the decimal point. Though we provided some number of digits after the decimal point, it will not read all the digits. It reads only 2 digits after the decimal point. Okay, so that can be achieved using this precision function. And third function is fill. Third function is fill. So here what is the use of this fill? So fill is to specify a character that is used to fill the unused portion of a field. So here it is used to fill the unused unused portion of a field. That is, by using this width, I specified 10 size, 10 characters as its width size, but I printed only 5, and remaining 5 characters will be empty only. Okay, so are unused for that particular output. Okay, if that is the case, I want to fill that unused characters with some character, special character. So that can be achieved using this fill function. Fill function is used to specify a character that is used to fill the unused portion of a field. So normally this follows with the function with. Okay, because here it reserves some number of characters and it uses only some characters. So remaining characters are part of this output only. So in order to specify here, we use fill function to fill these unused characters or unused spaces with some special character. So normally this fill is combined with. Okay, these two comes in a single statement. Next function is setf. So here F means flag, set flag. Okay, and it is used to specify format flags that can control the form of output display. So here set flag consists of or it contains format flags. And what is the purpose of these format flags? That can control the form of output display. That is here the format flags controls the form or format of output display. Okay, so that is specified using this setf function. That is as we discussed. Normally by default, when we are displaying some value, that is left justified on the screen. Left justified. If I want right justified, okay, or center, right justified, or center, then I need to use this set f. Set f. I need to set the flag, which flag, right justified or center, so that this particular uh, operation performed on the next output display or next output statement. Okay, so that is the use of setf. Setf is used to specify format flags that can control the form of output display, right? And unsetf, unset f. So whatever the flags we set, here we are unsetting those flags to clear the flags specified by the setf. Whatever the flags we specified using this setf, if we want to unset or to clear those flags, we need to use the function unsetf. Okay. Now we'll discuss each and every function with its syntax and one example program. Right. So first function is width. So here we used to set field width and number of character positions for output. That is here we specify the number of character positions for the output to be displayed on the screen. And this width can be used on input or output. For input operations or even for the output operations, we can use the function width, right? And it specifies field width for only one item. When we are using this particular function width, it can be applicable for only the next input or output statement. Input or output statement, not for some set of output or input statements. This width will be applicable for only the next input or output statement, only for one statement, not for the set of statements. This cannot be applicable. So here it specifies field width for only one item, right? Next, revert back to the default after printing one item. And after printing one item, obviously, as we said, we discussed, this is used to specify field width for only one item. After performing or after printing that particular one item, again it simply revert back to its default specifications. Okay, default values. That is, again, normally it starts from left justify. Okay. So here it revert back to the default after printing one item, because this can be applicable for only one item. Next, fill characters and padding used when output too small for width. That is, as I told in that is previous slide. See, this fill will follow width. Okay, so here fill characters are padding. So these fill characters used when output too small for width. That is, we specified 10 characters, 10 positions, character positions for the width, but we used only 2, 3, or 5 characters or 8 characters. Then what about the remaining 3 or 5 or 7 characters? So here we are filling these positions with some character. Okay, so that can be possible. That is used when output too small for width, and large outputs are printed, not truncated. Okay, so those will be printed. So here width simply sets the field width, that is the number of character positions for the output, and can be used for both input and output operations. And when we use this particular bit, it can be specifies field width for only one item. After printing that one item, it revert back to its default values, and even we can fill the empty characters, reserved characters or blank spaces with some characters, special characters using this fill. Okay, now we will see one example here. This is the syntax for width. So the, as we said, all these are the member functions. All the five functions which we discussed, that is width, precision, fill, setf, and unsetf. All these are the member functions. If how we can access the member function, using only the object we can access the member functions. That's why here I use this dot operator. This is the object, cout dot width. I am calling the member function width by passing number of characters, or by specifying the width of the field. Width of the field. Okay, this is the syntax. Cout dot width. We need to specify the width, field width, right? And if you observe this example, simply here simple that is a program void main cout. Initially I am printing star. Okay, and cout width, I specified the field width as 10 characters, 10 characters, and I am printing after that 12 followed by star. Okay, so what happens if here uh, we have written a program like this. Now let us open Turbo C++. Okay, type the program here, hash include, and hash include. Okay, into main. If you want to use documentation section also, you can specify here cout simply one character. Okay, and after that I am printing, I am calling this width function using the object cout. So cout width, and I am specifying the size of that field, that is 10, and after that I am uh, printing some number 12, and for our best understanding purpose. I'm using star also. Okay, and as usual, let ch return 0. Okay, now save the file. Save the file with okay. This I have a function at with function. Let's save the file. Now compile the program. Let us run the program. If you observe here star and followed by some spaces because here before printing 12 we specify the width of that next or the item is 10. So here sorry here we are getting that only. These many number of times we executed. So from first one star spaces 12 and 1 star. Okay, three times or okay, three times we execute. That's why we are getting like this. Star some spaces that is here. That may be 8 spaces. After 8 spaces, it is printing 12, and immediately it is printing star. That means here what we are able to know this particular that is effect will be on only for one item. One item. Though here in this layout we used to output statements. Here we are printing 12 as well as star. Okay, but this specifies or it affects only one output statement, one item, only on one item. That's why in order to print 12, we are getting that is 10 width for this 12, and we are getting this 12 as output, that is at the right side. Okay, but here this 10 is not applicable on the in order to print the star. Not only that star, even if you are specified some other value, it is not affects that. Okay, not affect on that item also or that value also because here specified that will be applicable for only one item, right? One item. Save the program. Again, compile the program. Okay. Now run the program. See, only for 12 it is that width is affecting on the output 12 or only one item, that is 12, and after 20 next item is 23, simply it is printing without having that effect on this, and even the star, even the star. Okay, this is use of width, use of width. Now move to our uh, next function, that is precision. Okay, so here what we do here, what is the use of this particular function precision? It can specify the number of digits to be displayed after the decimal point. So what is the main purpose of this precision? It specifies the number of, normally if we want to print uh, okay, leave it. Hmm. Okay, so here what is the use of this? plot 123.456. Now, here can specify the number of digits to be displayed after the decimal point. This is the decimal point. Okay, after this decimal point, we are having 4 digits. Okay, but here we can specify the number of digits to be displayed after the decimal point. If I want to print only 2 decimal points, that is 123.45, I need to specify that 2, because after decimal point I want to print only 2 digits. That's why I need to specify them in this function 2, precision 2. So it displays only 2 digits after the decimal point. If that is 3, then 4.456. If that is 4, 0.4567. If precision 1, then only 123.4. Okay, like that it can specify the number of digits to be displayed, right? And after the decimal point, and default precision is 6 digits. Normally it can print 6 digits by default. 1, 2, 3, 4, 5, 6. Okay, default precision is 6 digits. If you are not specified, if you call only this precision function, then by default it will take 6 digits as its value. And precision setting stays in effect until it is reset. So unlike as width function, here this will affect, or this setting stays in effect. That is, whatever we specified here, that will be in effect until it is reset. Until it is reset. After setting that is precision as 4, until and unless I again changed, or I again call this precision with 2 digits, only that 4 digits will be effective. And trailing zeros are truncated. If it is having some zeros and we set precision as 4, okay, we will not get 123.4500, because here these are trailing zeros. So these trailing zeros will be truncated. Though that is 4, we are not getting 4 digits of the decimal point. Only we will get dot 45, because here all the remaining digits are zeros, right? Now, what is the syntax? What is the syntax? Here, this is the syntax of that. Cout dot precision, and we need to specify the number of digits to the right of the decimal point. We need to specify the number of digits to be displayed on the screen. Okay, this is the example program. So here the simple one, before printing the square root of 2, I am setting the precision, that is 3, and even I am printing some other values, that is floating values. Cout 3.14159, that is with 5 digits, and next one is with 6 digits. Okay, so if you take the same example, now we'll check what may be the output. So hash include h, sorry, h, and hash include h. Okay, and int main, right? Even now I am using this clear screen. Then I am calling the function precision using cout object precision, and number of digits to be displayed is 3. Okay, next cout, I'm calling some math operator function square root of 2. Okay, and dash and new line next statement to be print C out and some value 3.14159. This is the value of pi dash and next C out some value with zeros 2.500032. Okay, so close this, let's ch and return 0, return 0. And before saving this or executing, we need to include what? Hash include math.h. By here we are using square root function sqrt, that is a function which is declared in math. Okay, mathematical operations. So we need to include that, otherwise we will get an error. So now save the program. This is precision function. prefun. Oh, now compile the program. No errors. Run the program. See here. If you observe the output, square root of 2 is 1.414. So we are getting 1.414. And the second input is 3.14159. Though the input is 3.14159, here we are getting 3.142. Because here the third digit is 1, okay, and fourth one is 5. So whenever we are truncating, so obviously by considering the value of its next digit, that is 5, here 1 is added to 1, 1415. Okay, but 142 we are getting. 5 is greater and equal to 5. That's why we need to add 1 digit to its previous digit, that is 1. 1 we need to add 1. So we are getting 3.14. And next output is, the input is 2.5, that is we are displaying 2.50032. But as we discussed, one character of this precision is it simply truncates the uh, zeros. Okay, truncates the zeros. That's why here normally it has to print 2.500. But as those digits are zeros, it is simply truncating those zeros. So you are getting 2.5. You see, the first one square root 1.414. So 414 three digits we are getting the same. But here if you observe, we are having 5, precision is 4, that is up to here we need to get the value 3.141, but after 1 we are having 5. So what we learn, if that is 5, now 1 should be added to its previous digit. That's why we are getting 3.142. And what about this? Here normally it has to print till this 2.500 because precision is 3, but as these are the zeros, no value for those zeros, so we are getting only 2.5 as in output. Okay, this is the use of precision. And one more thing, when we compare with the width, here only once we specify this precision. Okay, but here we are getting that function is affecting all the other output statements until and unless again we reset that. Let me show you that also. After that, simply I am copying and paste. Here I am pasting and I am specifying the width of 1, 2, 3, 4, 5. Okay, I am specifying 5. So now compile the program. Okay. And Compile, zero, run the program. See here. First one is 1.414 and next one is 3.143. Next is 2.50003 because here we specified the for the third output statement we specified 5 as its precision. So that's why here we are getting that. Okay. So this is the use of precision. Even here 1 for 2. That's why it is added. 5 is greater than equals to and greater than 5, that's why 1 is added to this. Previously this is 3.141, but now we executed with 2, that's why there we got to 3. Okay, this is about precision. Okay, this is all that is by this we will uh, have break for today's lecture. Okay, in today's lecture, we discussed what is being formatted input-output operations, what is the syntaxes for C in and C out, how we can use those C in and C out in our programming programs, and after that we have observed formatted input-output basics in that how we can format the output or input, okay, that can be achieved using input output iOS functions and flags are manipulators, and we discussed some about this iOS class functions, that is normally it is having 5 functions with the precision fill, setf and unsetf, but here we discussed only with and precision with example programs. Thank you.